You are audible.
So good morning guys. Today we are going to understand augmented reality and implementation with Flutter, which is a frameworks design used to design the beautiful apps. So we will have these topics covered today. We will go through introductions and last two conclusions. So uh, let's begin with the what is AR. As we know, the basic definition is to bring down the virtual objects in the real world with help of technology. So, as we can see here, this device, this AI generated photographs is presenting the some some sort of contents which is in the form of augmented reality, and human can visualize it. So we have history for AR. It was coined first coined was in 1968 by Ivan Sutherland, and next he created also the type of device which is called a sword of Damocles, which was very heavy actually, and in next development in 1990s. The terms coined was by researchers Cordell, and in the upcoming year, this development was going on. In 1992, 1998, the NASA used the AR in the navigation, and in 2000, a game was introduced over AR, augmented reality, and in 2005. 2008 BMW introduced and 2009's and so 2018's ARCore, which is the SDK by the Google, is introduced, and now we have a much broader area for this augmented reality, which we will be understand in next slides. So these are some device evolution. First device was Sword of Damocles, which was very heavy to use, and next in as the time progressed, the device goes small and smalls, and now we know we have Apple AR and VR devices, and Google's also. So those are very sophisticated devices, and those are used to produce the immersive experience, which is the main in the augmented reality. So we will understand what is immersive experience in upcoming slides. So type of AR. So we have five types of AR. Number one is marker based AR. So what we need in this augmented reality experience, we need some sort of marker in the real world. So we can put on that marker the virtual objects, and markerless AR works on the technology like the augmented reality devices uh, gathered the surrounding information, and based on those information we can use the augmented reality. We have next projection based AR. Projection based AR are used to create the augmented reality objects by the help of some type of projector. So we have to create some shoes or some of the watches and other things that can like a hologram experience, but that is done by the projection. And superposition based AR, like we can see in the images here, that augmented reality, first we creates the models for this, and then that augmented reality are shown to the users, that how the experience will be. Like we have some broken monuments and other half of the things that can be shown fully with the help of superposition AR. We superimpose something over the other real object. And location based AR, we create the contents. Sorry. So location based AR means the developers create contents based on the locations, so that locations content can be shown in the augmented reality based apps, and users have much better experience, like we can see in the images here. So in the Google map or something, those shops and even the road distance and other things can be experienced immersively. So the very questions. So the most question is, what is the difference between the AR and VR? So AR is augmented reality, VR is virtual reality. What's the basic science difference is augmented reality does not share. Okay, so VR experience must be viewed in some kind of a headset. Like virtual reality can be seen in some kind of headset or other things, but in AR we don't need that kind of the devices. We can experience the augmented reality with the help of some smartphones and even some other devices. So. Augmented reality is direct or indirect live view of the physical real environment, and virtual reality create a similar. So we can see from here that augmented reality is just like we have to create the immersive experience with the help of augmented reality. But in virtual reality, the users actually saw the virtual content, totally virtual content, which even don't exist in the real world. So. So this is the basic difference between AR and VR. So augmented AR experience is done in many of the places like gaming. You can see two clients are playing at the same times, and businesses, we can see the clients are using the area for uh, understanding the and education. The students are learning the tornadoes with the help of AR. And non-profits, some of the clients are showing their whale endangered species. And in shoppings, clients understand or you experience much better uh, e-commerce product. And socially we can play and share some of the things over the uh, apps. So these are different user augmented reality experiences, and some are different, some are more there. So, what are the math behind the augmented reality? So, we have two are the broader area, vectors and matrix. Like and others are the coordinates and geometry, but those are come under these matrix and vectors. So we can see here we have two coordinates in some spaces, 3 and 3 coordinate, and -4 -1 coordinate. So with the help of these coordinate we can represent some of the object in the some of the object in our space. So that the same technology, like we have some object coordinates here and here, and with then we will take them in the matrix. This is the simple presentation what we use in the augmented reality 4 and 4 matrix and higher dimension. So we can read this. So what is a vector, and vertex are used for just the information of the object, and MEMS are technology, which is electromechanical system gyroscope technology, integrate the little chips well seated in the motherboard of the device. So what this done, so this understand the gyroscope and accelerometer, which we will understand in further device. So gyroscope and accelerometers use the gyroscope and accelerometers are fitted inside the smartphones, and and this technology use those small devices to represent the augmented reality. So what so how we have accelerometer. What does accelerometer do inside the augmented reality devices? Actually, these are the main components of any AR enabled devices. So accelerometer, we have accelerometer used to know the acceleration of the objects, like change in the velocity, and gyroscope are used to the orientation and position of the object. Like we have this camera, we have these devices, and when we rotate these devices in any direction, then the position and orientation of the devices will change, and that changes will be faded by the gyroscope inside the devices. And others, we have a magnetometers are used to know the location, like north and south. Camera are used to know the actual presentation of the view, and as these are the devices which creates the basic user experience for the augmented reality. So we will understand this motion tracking later. So what are terminology used in the augmented reality? First is the placing and positioning objects. Like um, if we have to put our virtual objects or augmented objects somewhere, so like we cannot put this virtual object over this real object. So first we have to know the where we have to place this, and for that users have developers should have to create the right positioning or placing for the devices. Like what should be the size of the device, what should the exact place or the surface for the device. Next is occlusion. Like we see in this images, this this chair, virtual chair, are uh, occluding this table. Like what is occlusion? This is hiding just the table, but good in the good augmented reality experience, this should not be. Actually, this chair should be behind the chair. So this is occlusion, which we will understand better when we go to next slide. So scale and size of the assets. So but our scale means the how we can increase or decrease of object size, and but size will be better to represent for the user. And lightning for realism means that if there will be a better light with the light sensor in the smartphones and other headsets, then the user can better experience the augmented reality. Like if in this image there will be dim light or low light, then it will be very hard to understand or the create the augmented reality experience. What is context awareness? Context awareness, what is in the surrounding for the augmented reality. So here this is a pots, and this is a cup, and other edges and vertex and surface planes. So everything's the device gather in their surroundings, so that create a context. So that's called the context awareness in the augmented reality. Solid augment assets This is the terms which used to just refer, but whatever model we are developers are creating for augmented reality, that model should be like the solid real objects, or if we go inside that virtual or model, then that should not that should not show like we are using some sort of virtual content. That should be like the solid augmented asset. So these are terminology and we used in the AR experience. So what is tracking? Tracking is the good so collect surrounding visual information inside device through scaling, lightning, spacing, motion, etc. So what we do in this tracking, just be our move our smartphone, and that smartphone or headset just gather the information. So that called the tracking, and that information are gathered with the help of lightning and spacing and motions tracking and scaling. These are others concept we understand earlier. And motion tracking we will go in depth in next slides. So what are type of the tracking? There are two types: outside in tracking and inside out tracking. So what happens in outside in trackings, every device cameras are fixed to the environment, like the devices are outside and we are create experience from outside in. And inside out trackings, what happen like smartphones, every devices are inside gyroscope and accelerometer and other things like camera and that sensors and everything's are inside just one devices. And that device are easy to move, like so this is better to use inside out tracking at the place of outside in tracking. So nowadays in every smartphone we use the inside out trackings. So ARCore is the SDK developed by Google in 2018, and which are used by the hundreds billions of devices. So every devices Android devices use the, even the iOS use the ARCore basically. Yeah, motion tracking. What happens when we open the augmented reality experience inside our smartphone? Then that smartphones start when we start to move the smartphones, then it start gathering the information of surrounding. So their AR core actually use this technology, SLAM and COM. The SLAM is stand for simultaneous localization and mapping, and current odometry mapping. So SLAM, what does slams just gather the cameras information, depth sensor information, light sensor information, gyroscope and accelerometer information, and then the create the better immersive experience. So the users or the client doesn't feel like he is watching some virtual content, so he or she watching some virtual content. So that's are the basic SLAM technology introduced via the ARCore. And the COM, concurrent odometry mapping, tells the smartphones where it is in the real world actually. So that can we understand better. Environmental understanding, the AR core enabled devices understand their environment by gathering the device sensors information. So for that we have some terminology and their definitions, like number one, pose. What is pose? Any object position or orientation to the world around it. So this is basic if we have to create the virtual objects or augmented objects. Feature points we can see here when we open the AR enabled device. Then these feature points are created on the surface where we have to put our augmented objects. Plane findings. Planes are The plane findings are the sorry. So plane findings are some of the challenging tasks for the AR core. Like uh, it can detect the plane over some non-plane area when because of its shortcomings, which we will understand in next slide. Planes we can understand like in the air core some of the 2D surface. And what are the anchors? Anchors are the mechanism by which you can attach virtual content to a trackable real world points. So anywhere we have to put objects or we have to create some augmented reality experience, then we have to put their anchors, or like two users in the different places have to experience the augmented reality based some game or something. So there are the use of the cloud anchors. So cloud anchors will understand where actually the object have to place in the real world. So we will understand cloud anchor in next slide. So some of the constraint with the current AR, which is the user interface UI metaphor. What is mean by this? Like in every devices we use the QWERTY keyboard. In computer, smartphones, and even some others devices. So that can be used easily in the UI interface in the AR. But what other language means? Like two users are using the augmented reality. So how they will understand what is mean by the anchors and what is mean by the other pose and some. So actually the language is not defined so far. Proper language is not defined for the for the augmented reality experience. So that is called the user interface metaphor. And other is the power, heat, and size. Like smartphones and other devices, AR enabled devices gather a lot of informations from that. At the same time they gather a lot of information like camera, the accelerometer, gyroscope, and others thing. So they need the real times processings at the high level. So that create a lot of power, heat, and for that is some of the constraints. And light, if there will be no light, then or low light, then user AR experience will be very bad. And 3D designs, like developers create the 3D models, and those 3D models are fitting in augmented reality experience or not. That's one of the challenges AR facing right now. So, and others are the computer visions, like how we see the real world and how the augmented devices see the real world is totally different. So for computers, the visions are created with the help of gathering surrounding informations, so that informations are perfect or not. So that's are the constraint for computer vision. Yeah. So shared cloud anchors. So two users are sharing the same experience. Then they have to share the cloud anchors, like position the augmented objects in the real world. So in this video, the two users are playing games and they are sharing the anchors and the virtual objects. With the help of that, they are able to play. So from camera, smartphone camera to this distance, and for this user from smartphone camera to this distance will be a pose for the smartphone. So that pose and other anchors like these distance and other things will be stored on the cloud, and two users can share the id for that anchors and can download the anchor and just play the games and can see the new objects and experience some of the business e-commerce thing and other things. So these are the shared cloud anchors which are done by the AR codes, and we can take their API and use this. So in this slide, we will understand the Flutter AR setup. So first, we need to add the dependency. We have two plugins here, like AR Flutter plugins and AR Core Flutter plugin. So AR Flutter plugins are used for both Android and iOS. Android devices basically used the ARCore SDK, and AR Flutter plugin are created top on that SDK. So minimum version is used, or minimum SDK versions in our app level build.gradle file is used 24, because below that ARCore is not supported. And for iOS we can download the pod files from here, which gives the permissions for camera and others things. And in manifest file we can take the user permission with the help of this, uh, and we have to add the app level build.gradle this implementation for creating the ARCore engines. So uh, I will show you some of the created. Okay, so we have some sample augmented reality experience. Okay, so we can see the feature points here, and this is the real augmented objects which are we fetching from the web, and we can put some of the more objects here. Yeah, and we can also use the texturing or planes for like this is the experience which we are creating texturing the plane. So okay, so we will understand something more about the programming used in it. Like I show you the first, the remote objects. So this is the AR core plugins used here. So AR core plugin, we have a controller for AR core, and that controllers have different methods to create objects, scaling, resizing, and rotation, orientation, and transformation. What is transformation? Transformation are the actually translation and rotation. Translation mean we have to move our object from one place to other place. So how that translation will be done, and rotation are we have to move our objects on some spinning point. So that's our rotation. So these transformations are basically used inside our uh, app. So here we have a translation method, and we have rotation method, and we can scale our objects. Um, Okay, so this one are using the ARCore Flutter plugin. That this is a different from AR Flutter plugin, which is different from ARCore Flutter plugin. So here in this plugin, they are using the four managers like session manager, object manager, anchor manager, and location manager. We can refer from their name. Session manager are used when the AR view or as a new AR session started. So this handle all the activity, and object manager or handle the object activity like the nodes and other things which we see just before the red color object. And anchors are where that object will be positioned, this handle. And location based are where the object will be placed in the real world, like on the road or in some building or some other location. So this handle that. So when we initialize the session manager, then the AR view started, and this for images start to texturing the path automatically. Yeah. So the node, basically here nodes are the object they are referring to, and anchors are where we have to place the object. And this is the method on plane or point top taped are used to just create a new object. So hit test. What is a hit test and recast? And these are the two broadly used terms. Hit test are used to create the object on some plane. Like we have to tape the screen, then the first hit test occur or recast occurs. So this when okay, let's move again to our slide. So these are the Flutter plugin managers which we see just before, and these were the widgets, AR view widgets inside that, and AR session manager, anchor, AR node. Nodes are that objects, and the beautiful things about the AR core, they are using the separate file extension like GLTF and GLB. GLTF are used to JSON and ASCII format, and GLB used to store the model in the binary format. So these are two different file extension used to store the models inside our AR enabled apps. So these are some mega players in the augmented reality world like Meta, Google, Apple, and they have different platform. Google Meta are using Meta Spark Studio to create the models and other augmented reality experiences for the users. Google are using ARCore, and Apple are using the ARKit platform for their users. and we have approx 1 billion mobile reach uh, for the augmented reality enabled devices, and pro- we have 2022 prediction was 15 billions around revenue, and in 2027 this will be around this 40 billion. So the future is actually very bright for this augmented reality, but we have lot of constraints which have to overcome by developers and others, model designer, texture designers and others. So thank you.